Hello dear students, welcome to third lecture on artificial intelligence. Our today's topic is artificial intelligence techniques. So let me share the file. So basically there are various techniques by which artificial intelligence is implemented, that is intelligence is imparted to machines, or how the machines are compared with various types of finite state machines, that is agent and hardware of the machine is compared with the finite state machines that we are going to study. So basically describe and match. This is the first artificial intelligence technique which we are going to study. In this technique, systems behavior is explained in terms of finite state model and computation model. Whatever the system is there, AI implemented system is there, we are comparing that system with a finite state model and computation model. You must have studied in digital electronics, Moore machine. What is a finite state model? What is a computation model? So details are given in the digital electronics field. Okay. So basically the finite state model consists of set of states, a set of input events and relation between them. Now what is a finite state model? It is having various states. For example, start state, middle state, end state, whatever the states are there, and input is given to each state, and a particular relation between is there between the state and input. Based on the current state and input event, next state of model can be determined. So how do we determine the next state in the model? It is dependent on the input which is given to current state. So computation model is a finite state machine which includes state of states, transition function and input alphabet. Now what is computation model? How it is different from finite state model? In computation model we have transition function. Okay, and computation model is a finite state machine. It has states, input events and transition function. Okay, so these three parameters are present in the computation model. In finite state model, transition function is not present. So in computation model, transition function provides mapping between input symbols, current state and to the next state. So what is mapping between the input and a current state? That is already known, and according to that mapping, next state is determined. So transition function gives the output according to mapping which is between input symbols and the current state. Okay, if a pair of states s comma s dash is such that one move takes a system from s to s dash, then transition relation is represented as s arrow s dash. Now there is a pair of state, okay, s comma s dash, and if the transition is represented, now we are moving from state s to state s dash. So how do we represent that transition? It is represented as s arrow s dash as shown in this document. Okay, so state transition system is called deterministic. In every state has at most one successor. Now this state transition system is there, it is deterministic if the transition is there, but the state has only one successor, means a sub-state. You can see there is a state A and state B. So there is only one state, sub-state, which is a state B. Okay, so it is called as a deterministic transition system. Okay. Now here state transition system is called non-deterministic if at least one state has more than one successor. Now here you can see there is a state A and there are two successors, state B and state C. A is having two successors. So such a type of system is called a state transition system which is non-deterministic. Okay. Now we will see the example of this technique, problem of towers of Hanoi with the two disks. Okay. So what is the problem definition? Move the disk from leftmost post to rightmost post with following conditions. Now see, in this, there is one disk, okay, and it is having three towers. All right, and in the first initial state, you can see there are two disks in one tower. We have to move those two disks to the last tower, but we cannot move that according to our own whims. There are some rules which we have to follow. And when we go from initial to goal state, there are various intermediate states which we need to go through. Okay, fine. State 1, then state 2, then state 3, like that. So there are various intermediate states between initial state and the goal state. So what are the rules? A large disk can never be put on the top of a smaller one. While moving the disk from one tower to another, you cannot put a large disk on the small disk. Only one disk can be moved at a time from one peg to another. At a time, you can only move one disk. You cannot take two moves in one instant. One move in one instant. The middle post is only to be used for intermediate storage. Now you can see the middle tower. Middle tower is not a final storage. For intermediate state, you can use middle tower. Final state is the last tower. Complete the task in smallest number of moves possible. And we have to move from the disk from initial state to goal state with the smallest number of moves possible. Moves should be minimum. So let's see. Here we will total we are requiring eight transitions to reach from initial state to goal state. Now you can see in the initial state there is a larger disk, and above that there is a smaller disk, and other two towers, middle and end towers, are empty. So what we are doing, step number 2, we are moving the small disk to second tower. Okay, clear? One move, we are following the rules, one move at a one time. And then we are moving that small disk to the third tower. And in the fourth step, we are moving the larger disk to middle. And in fifth state, smaller disk to above the larger disk in middle tower. Okay. And after reaching the state 5, what we have done, we have moved the smaller disk to first tower. So first tower is now having smaller disk, middle one is having larger disk, and last one is empty. Okay, so we are following all the rules. In these rules, we have not placed bigger disk above smaller disk. We are following the rules. You can see the transitions. In the step 7, what is being done? The larger disk is moved to last tower, and smaller disk is moved to middle tower, and finally the smaller disk to last tower. So the finally we are getting the goal state. So these are the state transitions of problem of Tower of Hanoi. So similarly, the artificial intelligence machine, it is having various processes in it, various goals are there, various objectives are there, and they are interlinked with each other via, means states are interlinked with each other. Step by step, the working is done. So this is an example. Okay, so that's all about today's lecture. I hope you have understood this topic. If you have any problem or doubts, you can ask me in the comment section below. Please like, share, and subscribe my channel. Thank you for watching. Bye.